So, now we will come to the example which we were talking about. So, let us have a general thing first. Find out the Bose-Select basicity, that is CO to SiO2 ratio for the following given condition. So, assume that 30% of the coke S is released above the TUL level and is incorporated in the Bose-Select. Final select basicity is 1.1. So, that is given. The final select basicity is given, which is means ratio of CO to SiO2, and coke rate is 600 kg per ton of hot metal. Coke contains 10% S, which has 45% SiO2 in it. Iron ore has 64% iron in it and 5.5% SiO2. Because we are talking about the basicity, so we are interested mostly in the CaO and SiO2 ratio. So, we are concentrating more where the CO and SiO2 is present. So, mostly SiO2 comes from the coke and from the iron. Consider 92% iron in the final pig iron. So, 92% iron in the final pig iron. Remember what it says, assume that 30% of the coke S is released above the TUL level. This is an important one, because coke contains 10% S. So, 30% of it is being released at the TUL level, remaining is going down in the Bose, the earth. And so, this is the case 1. In case 2, find out the Bose-Select basicity if the S contained in coke is 20% and coke rate is 650 kg per ton of hot metal. So, all other things are same, except that the percentage of S in coke is now 20%, and therefore, the coke rate has also increased to 650 kg per ton of hot metal. In case 3, we consider a lean iron ore, which has 50% of iron instead of 64% and has 14% SiO2 instead of 5.5%. So, naturally, the coke rate also is increased to 700 kg per ton of hot metal. So, all other things are same. Again you calculate the Bose-Select basicity. In case 4, consider the lean ore data like this, but S content in coke is 20%, this like case 2, and the coke rate is 750 kg per ton of hot metal, because both the places now S content has increased, SiO2 content. So, calculate the Bose-Select basicity. So, let us see how does it this composition affect the Select basicity in Bose region with the composition. So, in case 1, the input is iron ore, which is having a 64% of iron, 5.5% of SiO2. Coke consumption is 600 kg per ton of hot metal. Coke S contain 10%, coke in coke S is 10% and which contains about 45% SiO2, and final select basicity is given 1.1. So, we have to do a bit mass balance. So, that how much ore actually we need it. So, pig iron is saying contains 92% of iron. So, if we consider 1 ton of pig iron as a basis, so let X be the amount of iron ore required for producing 1 ton of pig iron. So, iron balance would be like iron input equal to iron output. So, 64% iron is given in the ore into X, that will give the iron input, and iron output pattern basis we have 92% iron in the hot metal. So, that gives you the ore requirement is about 1437 kg. So, that many kg of iron ore is required. Now, once we know this iron ore, we can calculate the SiO2. So, 5.5% of SiO2 is present in the iron ore. So, total SiO2 would be multiply this convert it into mole fraction. Now, fraction that multiply with the iron ore pattern basis which is needed. So, you get 79 kg of SiO2 which is present in 1437 kg of iron ore. Now, coke rate is given 600 kg per ton of hot metal, and S content in it is 10%. So, and in this 10%, so what how much S is there? Again the same way we can calculate at about 60 kg, but this 60 kg contain only 45% SiO2. So, SiO2 present in this would be the fraction of this and multiplied with this 600. So, that will give you 27 kg of SiO2. So, it should be actually 60 because we are calculating in this 60 kg of S. So, it should be 60, then only you will get about 27 kg. So, make a note of this, this should be 60, not 600. So, total SiO2 in the ore 79 kg is coming from the iron ore, and 27 kg is coming from the coke. So, total SiO2 would be 106 kg, 79 plus 27 equal to 106 kg. Now, total lime to be added as CaO for the liquid for the final. We know basicity is giving, which is nothing CaO to SiO2 ratio. So, CaO to SiO2 ratio equal to 1.1. So, with this basicity SiO2 we already know it is 106. So, we can calculate the lime requirement. So, total lime is required about 116.6 kg in order to get 1.1 basicity. Remember this saying the final slag basicity is 1.1. So, based on that this has been calculated. Now, we know this, and now we have to see the case 1 which says 30% of the S which is released from the coke above the fuel level. So, 30% is going, and which is actually will be contributed toward the formation of the boss slag. So, silica released above fuel level. So, we know 27 kg was present, 30% is being released. So, which is come to 8.1 kg. So, this is the amount which is being released above the fuel level, which will form the part of the boss slag. So, total silica in the boss region coming from the ore is about 79, and coming from the S is about 8.1. So, that gives 87.1 kg. Now, lime will not change. So, which we already got it 116.6. So, this CaO to SiO2 ratio would be 1.338. So, look at that 1.338. So, as we said even before when we were discussing 3 types of slag, primary slag, boss slag and the final slag, we mentioned that in the boss regions usually the basicity of the slag is higher. So, you can see the final slag basicity is given 1.1, that is actually in the hard region, and in the Bose region the slag basicity is 1.34. So, higher than the final basicity. Now, if we come to the second case, where what it is saying, the S content in the coke has increased from 10 to 20% and coke consumption from 600 to 650 kg per ton of hot metal. All other data are same. So, naturally the S total silica in the S will increase, because 45 this will give the total S in the coke. So, 20% S in the coke. So, 650 is the rate. So, this will give total S, and in total S 45% is silica content. So, that going to give you total silica present in the coke 58.5. Now, iron ore is not changing. So, whatever it was before 1437 kg, it is same. Percentage of SiO2 is also same in that, which we calculated 79 kg. So, total silica would be silica present in the ore plus silica present in the coke 137.5. Total CO for the slag having the same final basicity of the final slag 1.1, it has increased to 151 kg. So, look at that from 116 to 151, it has increased substantially to maintain this basicity of the slag as a final one. So, this much lime you need. Now, because the S which is released in the Bose region is 30% from that. So, we have 50.8.5 in the coke. So, 30% of it 17.5. So, total SiO2 in the Bose region would be 79 plus 17.5 is a 96.5. So, slag basicity naturally a ratio of CaO to SiO2. So, CaO is 151 and SiO2 is 96, that gives about 1.6 your basicity of the Bose slag. So, it is a substantial increment of the basicity in the Bose slag in comparison to the final slag in the Hearth region. So, by increasing 20% of this, because you have to add extra lime requirement increases, which contribute also toward the higher basicity of the slag in the Bose region. Now, we look at that lean ore. So, it says the 50% of iron in the ore and 14% of silica, and coke rate has also increased to 700 kg per ton of hot metal, but coke S is same 10% and S, and in that one 45% silica, and final basicity of the slag is still 1.1. So, output again we can use our calculation based on per ton of pig iron. So, iron input same calculation as we have done in case 1. So, I am not repeating it here. So, iron input equal to iron output, simple mass balance. So, 50% of iron into x amount of ore, that is a input, and 0.92 is the iron in pig iron in 1 ton. So, that gives you the requirement of ore is 1840 kg, while when it was a 64% iron or in one way iron rich ore, that ore requirement was almost 400 kg lower, as you can see in this one 1437 here, and here in this one we have 1840 kg. So, that is a substantial significant increase in this. So, now based on this we calculate the S content in coke 10%, coke consumption is this, total S in silica. So, this is actually in the ore what we are calculating. So, total silica in the ore, because it says 14% silica and ore we got 1840. So, in friction form 257.6 kg silica in iron ore and silica in coke in the form of S. So, this first figure gives this one as the total S in the coke, because 700 kg per ton of hot metal 10%. So, 0.1 into 700 total S, and in that S 45% SiO2 multiplying with this gives you the total silica in the coke, total silica in the ore. So, total silica is 289.1 kg. Now, total CO, again we are maintaining the final slag basicity 1.1. So, your CO requirement would be 318 kg. Now, this 318 kg, of course, we put it in the starting. So, when it is coming it would be the same that much. However, the silica content in the coke in the Bose region would be 30% of it. So, Bose's silica from the coke is 30% of it would be only 9.4 kg. So, 9.4 kg plus 257 kg which is coming from the iron ore would be the total silica which is present in the Bose region. So, if we look at that, so that gives you 267 kg silica, and our lime requirement is 318. So, this gives you about 1.2 basicity in the slag region. So, this is really not very high if your ore is lean in iron, and then the slag basicity in the Bose region is slightly up than the final slag which is 1.1. So, lean ore, that is why has disadvantage in this form. Now, if we look at the case 4, so in fact in we will come back on this comparison again. Now, in case 4 what we said, the S content in coke is increased to 20% and coke consumption is also increased to 750 kg per ton of hot metal. So, total S in or total silica in the coke S. So, 0.2 into 70 will give the total S content in the coke, and because it has 45% silica. So, multiplying this will give you 67.5 kg silica in the coke S, and this is not going to increase because this is still lean ore we are taking, and for lean ore we already got the silica content 257.6 and plus 67.5 from the coke S, it gives you 325.1 kg total silica. Now, because this is 67.5, so substantial increase in this, 30% of it now before the 30% of it goes to Bose. So, 67.5 and 30% means 20.25 only. So, total Bose silica is 257 plus 20.25 0.25 gives you 277 or 78. However, our final slag basicity is still same 1.1. So, we can calculate the lime requirement in the slag is above, which comes to about 357.6 kg, because total silica is 325. So, now we know lime requirement is this, we know the total silica in the Bose region is this. So, the Bose basicity actually is about 1.3. So, with higher coke consumption, or not just a little higher coke consumption, if coke is also of inferior quality where you have ash content more, then your basicity of the Bose slag increases to 1.2 or 1.3 in comparison to the previous case where it was 1.2, and this is of course higher than the final slag composition in the earth. So, so this is 1.3. All these examples you can see that Bose slag basicity is always higher than the final slag basicity in the earth region. This calculation shows you how you can calculate the basicity of the slag, which could be suitable to get the final chemistry of the metal and proper liquidus solidus temperature in the Bose region and the cohesive zone and in the earth. So, and so this calculation, as you remember when we were doing mass balance for the raw material charging and finding out the composition of liquid iron, we prepared the Excel sheet, and that was much easier than doing this way the calculation, which takes a longer time. So, I would recommend that you do all these calculation on a Excel sheet. In fact, the next slide will show you about that. So, if you look at this, this of course I cannot in the slide form I cannot show you that. If I go if I come out from this slide form and I double click on this, then actually this is embedded Excel sheet in this, and if I change any I can change the input, I can change any output. As you can see in the case 3, our final basicity in the Bose region was 1.19 when iron was 50% in the ore. If I change this to let us say 55%, and then we can see immediately what would be the effect of it. So, if we change to this, this immediately gives you the basicity is increased to 1.2. So, instead of 1.9, and similarly if your iron content, so you can change any of these variable which are here. Now, SiO2 content seemed a bit high. If I instead of 5.5 or 14%, let us say in case of 4, I make it to 10% in this, then I can okay. So, this is I think I make it 10%. So, the basicity is 1.2329 as we saw. If I put it this 10%, then I can see what would be my basicity has increased to 1.35. So, this is a good advantage of doing all this calculation on a Excel worksheet. So, you can change any of these parameters. So, like here I changed to 10% SiO2 in iron ore, my basicity in the Bose region of the slag is about 1.35. I change the iron input to 55%, my basicity has increased to 1.2 in the case 3. So, like that you can study and you can manipulate the slag or basicity composition in the iron making operation. This gives you the summary sheet what we have done till now. So, like 64% iron, this is the iron percentage iron in iron ore, 64 and 50% case we took. Output was always constant. Based on that, your iron requirement was changed, and of course the SiO2 was changed, and coke rate also changed. So, based on the coke rate and knowing the S content in the coke, our S and SiO2 we kept constant in the S, our SiO2 in the coke also changed, and based on that we calculated the total SiO2 in ore and S, and then we kept our final basicity constant to 1.1. We calculated the CaO requirement, the lime requirement, and because the 30% SiO2 was there of total going into the Bose region. So, based on that we calculate SiO2 present in Bose, and with this and this adding them up we know SiO2, we calculated the lime requirement, and rest of that we calculated the basicity of the Bose slag in this form.